Hello, I'm Tristan, Israel. I'm project architect and computational designer.
I'm Stacy Eisenberg. I'm a project manager and I specialize in facade design.
So in this keynote, we are going to present you the Nouvel design philosophy and how architects transform each unique concept to geometry and challenging building. So who we are? So Atelier Nouvel is a French architectural company based in Paris and led by Nouvel. We are 125 people working on building worldwide. And what we do? So basically, we're working on architectural buildings, but civic buildings, offices, housing, interior design, and even urban design. What we are going to present to you in this keynote is our expertise through three main projects: the Louvre Museum in Abu Dhabi, the duo office towers in Paris, and Matarato, a residential and hospitality high-rise tower in Sao Paulo.
So the first case study is the Louvre Abu Dhabi with its feature dome. The Louvre Abu Dhabi is located on the Sadayat Island in Abu Dhabi in the United Arab Emirates. Its gross surface area is 63,000 square meters. Its net surface area is 22,500. The dates of the design were from 2007 to 2015, and the construction from 2013 to 2017. The building is a classical art museum, and it's situated in the new cultural district on Sadayat Island. There's a 30-year cultural accord with the Louvre and Agence France Musée, Paris, for long-term loans and acquisition assistance. The museum is considered to be a museum city. It has permanent and temporary exhibition spaces, children's museums, auditoriums, restaurants, cafes, boutiques, an administration building, and art workshops and storage areas. The Sadayat Island was conceived as a cultural district. Several well-known architects were to build renowned projects on the island. The AJN project is the Louvre Abu Dhabi. The Frank Gehry project, Guggenheim Museum, is also under construction, and there would have been, or will be, a performing arts center by Zaha Hadid, a maritime museum by Tadao Ando, and a Zayed National Museum by Fosters and Partners. Generally, when we begin a project, there are many areas of research for the concept of the design. And most of these areas of research are based on the content and the specificity of the place. There are three grand areas. One is the place, the geography, the history, the culture. In this case, it's where the desert meets the sea and that border. We also look very closely at the history and the typologies, and in this case, the museum city and the layering of the archaeologies of the area. And then there's the vernacular, the climate, and the environment. And these are ways of looking at traditional approaches and dealing with the microclimate and the features such as shade, shelter, and sunlight. These are some of the initial sketches done by Nouvel. These are some of the initial massing plans, and there are two key elements in these massing plans. In this one, there's the water element, which is the blurring of the boundaries between the desert and the sea. And the second key element was the dome, and that was the incorporation of very specific light and shade. The basic geometry of the dome is a slice of a 349-meter diameter sphere with a span of 180 meters and a rise of 25 meters. At the base, there's a support, a belt truss, which is 6 meters deep. There are also 4 structural support elements which span 110 meters between supports, which are hidden within the buildings of the museum. The dome. The primary structural grid is a structural steel space frame, 6 meters deep, made of 10,000 structural components, pre-assembled into 85 supersized elements, each weighing on average 50 tons. Structure and cladding. There are 8 layers of cladding. There are 4 outer layers clad in stainless steel and 4 inner layers clad in aluminum. There are 7,850 unique stars, creating a layered series of geometric patterns, allowing for approximately 1.8% of the dome to be perforated. The base pattern is an isosceles triangle, repeated, rotated, scaled up and down to form a system of squares and hexagons. Pattern then mapped onto the dome surface to be true at the apex and distorting outwards towards the perimeter. The cladding patterns used to control the light, intensity, the direct sunlight, and the temperature. Structure and layers. The base structural steel space frame also formed a pattern, as well as the framing assembly, and then the cladding assembly, the layers of the cladding assembly, to achieve light attenuation as well as light control. And these are some of the studies and the long research that was done on the different openings within the dome. And images from the exterior of the museum and the dome. The dome acts as a light filter as well as a light source. And the research that was done through various mapping techniques. There was a light intention map to analyze the light and temperature controls, an inverse lighting analysis, which analyzed the light and shadow, and a transparency map, which analyzed the perforations mapped out and translated. So these are views of the lights moving and the patterns moving and the different types of patterns throughout the day. And these were calculated with the angle of the light and the incidence of the type of light as well as the type of pattern. And this is a conceptual image of the rain of light, the light typology and the light patterns. We did many study models, some in-house, to analyze the light, shadow, as well as the different perforations. These were done outside of the office. There was a prototype model done at 1:33 scale. And then there was a full-scale mock-up and prototype. The preliminary studies showed 10 distinct superimposed layers of cut aluminum panels. And the light variation was analyzed for its intricacy, and the structure maintained consistent points of connection. There was also analysis of the temperature to be included in the studies for the microclimate underneath the dome. The preliminary prototype was built on site. You can see the beginnings of the cranes behind. This is a view from the exterior. And this is a view from the interior where the analysis was done on the different lines of the rain of light, as well as the light that was captured within the dome itself, and mostly the patterns on the floor and the walls as they moved throughout the day and changed their sharpness and their forms. We constantly refer back to the conceptual images while we're doing these studies to keep in tune with the original ideas that were put out in the 3D renders. So these are the first images of the construction site with the prototype to the left. The first images of the dome with the museum underneath under construction. The patterning of the stars as they go into place on the dome. The positioning of the stars and the different layers. A view from a distance. And the last piece of the dome cladding was installed in 2015. And these are views of the final project from the interior inner courts out towards the sea. The inner courts looking up towards the dome, as well as the gangways inside the dome. And then the light patterns. So once again, the light was not just a rain of light. The light was also captured within the dome and lit up areas of the dome. But mostly the analysis was also on this kinetic form of light as it was transferred through the dome onto the areas below. how it moved, how it vibrated with the water patterns and the angling of the sun. At the end of the day, the patterns became very long and very soft. In the morning, they were sharp and much more concise. These are on the water areas. And as the sun goes down, the night views have also a kinetic to them, as if this was a celestial vault. The stars come out from underneath the dome.
We're moving now to Paris, and we're going to present the project called Tour Duo. So the client is Ivanhoe Cambridge and Heinz, and the program is like offices and hotel and retail, and a restaurant on the upper part of the first tower. We won this competition in 2012, and the construction started in 2017. We are going to deliver this project for the end of the year. So located in the eastern part of Paris, near the Seine, Duo is composed by 2 towers and a large public plaza. They are the last building at the end of the Avenue de France, and they are facing the Ring Road and an impressive opening on the railway. So the very idea from Jean Nouvel was to reveal this urban landscape, invisible from the ground. All the movement from the train and cars crossing the bridge has to become part of the tower's identity. So the project geometry starts from this intention to play with the reflection. At the really beginning, we wanted to create dynamic patterns composed by the reflection of the surrounding. Sometimes it could be really clear, and sometimes more abstract, and to have an interaction between the inside and the outside of the building. In order to reveal the tower from the main avenue and capture the reflection of the ground activity, Jean Nouvel decided to dramatically incline the towers. As you can see on this picture, the tower slightly coming in the streets. And all this inclination permits to emphasize the reflection of the train and the cars. Here is like some renders at the very beginning of the project. So from the Avenue de France, and here from the Ring Road, during the day and during the night. What is really important too, once the massing is decided, is the vocabulary. The vocabulary is each piece of this building had to refer to the world of train, vegetation, and moving lights. So we choose to illustrate through 2 key elements of the project: the reflection of the double skin facade of Duo 1, that is the tower on the right side, and the curved bristle of Duo 2 on the left side. So the first step was to precisely map the context to validate and control the initial idea. So here on Duo 1, we decided to use a double skin facade, and to realize this intention, we composed the facade thanks to 8 families. The first skin of laminated glass is porous and designed to both control thermal condition and reflect the context. The second skin ensures the air tightness and the fire protection thanks to the catwalk and the shadow box. All those geometry are drawn in a beam model in which all facade family are precisely referred and informed. In this beam model, we have all the information about the curtain wall and all the information about each piece of glass. So if there is an element like the height of the floor that is going to change, we are able to adapt all the project. One important point was to control the impact of the sun reflection on the ring road, and so we adapt the scale and the angle to comply to the city ring road requirement. As you can see on those slides, we are sure that we are not going to have any problem, any issue with the car because of the reflection of the sun on the road. We always control the geometry thanks to renders and thanks to visual mock-up, like a small prototype like this, 3D printed. And when it's decided, we jump to the full-scale mock-up, as you can see here, and we were really happy to see that the effect that we were looking for was present. As you can see on this image, you can have like the people inside and people outside. It's like blurring the reflection of the context, and it permits to have a play with the surrounding as we wanted at the beginning. The construction. So basically, this is an image where you can see like the reflection of the road on the facade. So works pretty good. And from the ring road, you can have, as you can see here, all the railway reflected into the facade with a gradient from the sky reflection to the ground. And as the light is changing during the day, we discovered like a really interesting effect of the reflection of the glass tube. Here we are going to present you like a small video because this effect was really important for Jean Nouvel as a dynamic effect. And all the cars are visible from a pedestrian point of view, and so all the context is revealed thanks to the tower. The second element is the brise-soleil of Duo 2. And in order to realize the intention of this wavy reflection, we imagine a highly reflective curtain wall with a curved brise-soleil. The geometry is a balance between needed solar protection, clean, clear view visibility wanted from the client, and important structural constraint, especially from the wind. Each blade is a 3-meter aluminum triangular profile combined with a 2-millimeter thin sheet of reflective steel. We control all the time the effect from the inside too, with this render, for instance. And all the geometry is coming from a complex computational design which takes in consideration the initial graphic wavy ID and the construction constraint. Here, from the generative surfaces to triangular profile and to curvature optimization. Indeed, to reduce the cost, we sort all the blade according to the curvature and achieve a simplification of 50% of the blades that we transform to straight profile. Here is like a render video to control the large-scale effect. And it's like if you're moving away from the tower and all the surrounding is playing with the sky and everything is moving into this facade. When you're getting a little bit closer, you can start to see the context and how the railway is creating a really abstract motif thanks to this triangular element and the reflection of the brise-soleil. So all these elements are confirmed thanks to models and visual mock-up again. So this is the really first visual mock-up we made. So it's 3 pieces of aluminum. We tried in steel, in aluminum, different metal. And here is this 1-scale blade in reflective steel. Full-scale mock-up, and some images of the construction. From the Avenue de France, we slightly distinguish the facade and the brises. And when you arrive near the tower, the effect becomes more powerful, and the surrounding is playing into this facade. It's really interesting to see it by night too, because when you're on the plaza, near the tower, you can see the light of the train going through all the facade. This is basically 1 week ago, and as we said, this project will be delivered by the end of the year.
The next project and final project is the Matarato Tower in Sao Paulo, Brazil. One of the original rendered images, conceptual images. So the location is the capital, Sao Paulo of Brazil. The project gross to net surface area is 54,000 square meters to 36,700 square meters. The height of the tower is 93 meters. There are 22 stories. The client is Alexandra Lara, and the design dates were from 2012 to 2016, and construction from 2017 to 2022 will be the completion date. This project is a renovation and a redevelopment of the historic buildings of the Matarato Hospital and site into a multi-use hospitality, office, residential, and hotel complex. It's also a revitalization of the urban center of the Paulista area in Sao Paulo. The high-rise tower, combined with the Matarato maternity ward, will become a 5-star Palace Rosewood Hotel. 151 guest rooms, 122 owner suites, with amenities including restaurants, bars, lounges, terraces, gardens, swimming pools, a spa, and a fitness club, as well as a private penthouse at the top of the tower. The materials are primarily exposed concrete structure, full-height operable glazing, exterior metal brise soleil, wood decking, exterior wood shutters, and metal and glass balustrades. Sao Paulo is a very dense city. In the greater Sao Paulo area, there are 21 million people, and in the center, there are 12 million people. And the density was one of the prime conceptual elements that was used on this project. Once again, we go from the concept to the context, the place, the geography, history, and culture, the density of the city, the vernacular and typologies, the layers and scales and patterns of the traditional favelas, well as the brise soleil. Being a temperate climate, the brise soleil are often used in Brazil. The climate and environment, which allowed us to interfere the exterior with the interior and bring the gardens inside. This is over a sky view of the actual site, which is in the red square, and you can see the old hospital, as well as the surrounding density. The main idea for this context was that within this incredibly dense area, that Matarazzo traditionally represented a clearing, and this would be a clearing in the forest of urban density. So these are some of the preliminary concept sketches by Nouvel, and some of the preliminary 3D concept sketches and layouts where we see the integration of the green into the layering of the external cladding areas. These are more 3D sketches of the preliminary layouts where we start to define how the cladding areas are layered and how they are opening one to the other. And some of the final concept images where we see the different brise soleil and the different greenery which is incorporated into the building. Because this was such a dense area, one of the ideas for the brise soleil was, of course, not just to protect the views in, but to allow for an animation of the views out. So we did many study models. These are some of the preliminary study models. Also preliminary study models where we started to define the layering of the brise soleil and the exterior cladding. A more evolved study model, which was built in Brazil, and some of the final showroom models. So the preliminary cladding and brise soleil studies. We did a prototype. The prototype was a showroom, so we were allowed the opportunity to define a duplex apartment, a simplex apartment, and a hotel room. The location is shown here on the Itapeva facade to the south. These are some of the 3D images of the showroom, which show the different studies on the brise soleil, as well as the cladding and glass splits. The geometry and density of the brise are driven by the heat calculations as well as the structural constraints. This is a sun protection study. On the left, you can see the glazing without the brise, on the right with the brise, which allowed us to calculate what the brise needed to be in terms of sun protection, intimacy, as well as views. These were one of the preliminary mock-ups of the Brise Soleil, which was done at the showroom on the area on the side of the garden. And this is the terrace area looking into the duplex apartment, which was built for the showroom mock-up. These are views from the inside out into the garden. The garden was also planted specifically for the prototype. To the left from the ground floor level and to the right from the mezzanine level. Some views of the interior and exterior brise. Some of the smaller terraces at the showroom, which were areas which included layering of the facade as well as the brise soleil, including in the layering was the reflection in the glass. And these were some of the brise soleil that were done to the exterior of the building with the vegetation almost incorporated into the brise. There was also a prototype that was done for the facades as well as for the brise soleil and the terrace areas. This tested a lot of the different treatments to the brise soleil, which was a simile Corten steel, although these are aluminum extrusions, and the color is done with a fusion of a film onto the brise. This was one of our first projects with exposed concrete, so it was interesting to see the concrete and how it reacted. We tinted the concrete darker, and that was a large amount of research that was done so that it didn't separate out into, which you can see in the prototype. That was fixed for the actual construction. The brise soleil were, once again, we worked in families. So there were different typologies that were used throughout the building. Here we can see a sample of how they were calculated into the families. There were approximately 21 different families, and the typology analysis took into consideration the program of the interiors, the intimacy levels, the sun protections, the views in and out, the lighting patterns, as well as determining the orientation, the element patterns, the dimensions, and the spans. Of course, there were subfamilies to the 21 families. And this is the construction. Here we see the Matarato complex with the tower at approximately level 6 in the middle right-hand corner. This is the Matarato complex where we're almost at the topping out. We're at approximately the 21st level. This is an image in 2020 where most of the brise have been put in place and they're installing the glazing. These are some of the views of the different brise soleil from the southern side. The southern and the north side had most of the brise because that's where the buildings and the proximity to the other high-rise buildings were. So as a protective measure, all of the brise were put onto the north and the south. And the two other west and east facades were open, one to the city and the other to the garden with the terraces. Here we see once again the south side. This is the side facing the garden where the terraces will be implanted up and down this facade. Most of the facade will be green. This facade is relatively open. It looks out onto the Matarazzo complex. This is the Itapeva Plaza, which is the entry to the south side of the building. And this is the garden side of the facade, which is to the north. It also includes many brise. And we see to the right-hand side the west-facing facade, which is open to the downtown views. We have a short fly-through film of the latest construction.
So we hope you appreciate this presentation, and we hope to see you soon in Paris, Sao Paulo, or even Abu Dhabi. Thank you very much.
Thank you very much.